All right, so jumping right back into it then, this term modern principles, I actually did a fair amount of searching around trying to see who had a definition for modern, and I don't know who made this up, but so really it's more thinking about how do you build apps today? Right? And that's really what we're thinking about from a modern perspective. Or if not, maybe how do you build apps? How could you build apps today? Right? I hate to say should, because there's a lot of ways that you can go build apps, right? But how could you go out and build apps today to try and improve on the processes that you currently have or have dealt with for a number of years? And so in here, we'll sort of talk about some of the things that we tend to think about in modern application development. Or in today's application development. And so one of the first things that's very popular, of course, is just standards-based, right? Being able to know that I'm going to be able to write code on one platform, consume it from another client running on another platform, and possibly host it on some other platform, right? So this ability to write once and deploy somewhere else and then consume it from pretty much anywhere is a big part of that. And so having open standards is a very important part of how do we go about doing that. And you can think about standards a lot of different ways. You could think of standards from an infrastructure perspective. Like, what's the format of my virtual hard drive? Do I have a format of a VHD that's shippable? Can I ship it between cloud vendors? Can I ship it between operating systems and use the same virtual hard disk format? Or it might come from a coding perspective, right? Node.js, can I write Node and run it on this platform or that platform or that platform? Or it might be from a, how do I consume services? You know, do I think about SOAP-based services or REST-based services and all that kind of stuff, right? So there's a lot of things to think about around, open standards. The other part, going back to leveraging frameworks, it's that same thing that I said in the previous slide deck, right? Helping you only write the code that only you can write, not making you write code that anybody else could have written, right? I just did an event last week that was live streamed, and we were talking about data access technologies. And to really understand data access technologies in the Microsoft stack, you have to first go back and look at good old ADO.NET, with connections and commands and data readers and all that kind of stuff. And I can't tell you how many times I wrote code to connect to a database, issue a query, get the data reader back, and then loop through the data reader, right? And you have like these 10 lines of code that set up all your usings and all the nestings and everything like that. And then finally, you get into the loop for your data reader, and you finally get to do something with it, right? You're like, why did I have to keep writing all that code over and over and over again? Couldn't we have just stuck that into a framework like Entity Framework and let that deal with it for me, right? So it's leveraging, it's going in and embracing those frameworks and letting them reduce the total amount of code that you have to write and the total code that you have to maintain. Services-based, if we're going to be looking at applications that can run anywhere, they have to be able to get to data that's somewhere else, especially as you think about mobile devices, right? Having an application on the phone, a simple game, might not need cloud-based data, right? But most apps want to either get data from somewhere or put data somewhere, right? And so we need to have some sort of standard service out there that can help me authenticate my users, that can help me store my data, and help me run my server-side logic. So this service-based idea is very important. We do a lot of testing, right? Unit testing certainly within the code application development itself. So individual devs, most of us are doing unit testing now. But then also as you look at, deploying a really large website that maybe the whole nation's going to use, you might want to load test it first. I'm not pointing any fingers. But load testing and all that kind of stuff, right? Certainly a big part of how we do modern application development. And tend to be very dynamic and have some virtual I'll use the word infrastructure, right? The ability to dynamically scale means that there's got to be some virtualization layer in there. I can't be sticking physical hardware into racks, right? If I want to be able to scale up or scale down on demand, right? So we need this sort of dynamic virtualization. And that could be on-prem, right? We certainly have virtualization technologies that we use in-house, or it could be in the cloud, right? Where we're pushing these virtual machines up into the cloud. Multi-tenanted, if you're building a product that you could use, it's worth thinking about, could somebody else use that same product, right? So if I go out and I build some infrastructure for myself that has mobile applications and that stores data in the cloud and supports authentication and has branding with logos and all that kind of stuff, how can you think about building that in such a way that you were simply one client or one tenant, right, in that overall application, right? And then being able to turn around and say, hey, now, not only are we using it for ourselves, but could we reuse this for others, right? So multi-tenanted is a big part of that. And it could be that you just try to have that foresight, or it could be that that's your business, right? We're in the business of providing services for our customers. And so I want to build that service model for how do we support one customer, but then be able to add additional tenants and sort of white label across those other customers, as you will. And then, of course, supporting end users that are coming in with their own devices. And so that really means having to support this multi-client architecture, right? I could have applications running on a variety of devices that are all connecting to sort of my back-end services out there. And these could be Windows platforms, iOS platforms, Android platforms, whatever it happens to be. And again, we said not just about the code, thinking about all those other types of services, right, that you can go and consume. So as you start to think about adopting the cloud, right, as a way of helping you build your modern applications, oh, I meant to get that slide out of there. Let me jump up one. Ignore that previous slide. All right. So imagine that you've got a website running on-prem, right? And you've stood up your own data center. You've got servers running somewhere, you got a firewall, you allow connections in from the internet. Some shops probably still do that, right? This could instead be a co-located type thing. But with co-location, you've really you're almost like, it's like you have a small portion of a data center that's still yours, right? It's still on-prem, and that's your premise. It's just their power, right? Or their cooling, or it was their locks that you had to go through to get into the room, right? Sort of stuff. But it's still your hardware in a lot of those cases, right? So I've got a server, I've got an ASP.NET website or some HTML pages. Somewhere in my storage network, I've got resource files, that kind of stuff. I might even have a database that's supporting back-end data for this application. And so I have a user sitting out here in the browser, and they can retrieve the website off my server. The website might go back and talk to a database on the back end. And then, of course, certainly have resources that the user has to download, like images and CSS files and all that kind of stuff, right? And so that's sort of the on-premise model, whether it's totally on-prem or if part of that was co-located. As you start to look at the cloud, though, you have the opportunity really to move any one of those three pieces any way that you like, depending on sort of what your tolerance for configuration happens to be, right? But one of the easiest things to do is to take your resources, JPEGs and CSS and all that kind of stuff, and just move those up into the cloud, right? In the case of Azure, that would be up in Azure Blobs, right? So we have a storage service that you can put blobs in. It's basically just like a file system. And so now my user would still retrieve the HTML file from my site, but my HTML file would say, oh, and by the way, the images are up there. Go to Azure to retrieve the images, or to retrieve the JavaScript files, or whatever static documents you might have sitting up there, right? And in fact, with our content distribution network capabilities, those could even be distributed globally so that they're closer to the users who consume them, right? So we use the server for the dynamic portion of the app, but we use static storage for the static pieces, and we put that up in the cloud. Benefit of that is, again, I'm moving all that traffic off of my firewall, so they're not coming in through my pipe. They're using Azure's pipes for that. And you could leverage our CDN to really get that stuff distributed out there closer to the users. Now, I should mention with a little asterisk, right now CDN onboarding is off. You cannot sign up for CDN right now. They're changing the provisioning process for that. But at some point, we'll get that back on, and you can leverage it. Existing customers are still okay, but we're changing the onboarding for that. You could also move your database up into the cloud, right, with SQL database. I'm not sure I'd recommend that. The latency between your on-prem website and the back-end database would be probably too high for that to be really a great story, other than maybe a step in the migration. But I'm not sure that I'd recommend that long-term. You could flip it the other way. I don't have that on the slide, but you could put the website in the cloud and keep the database on-prem. But now I'd have to configure a virtual network. And again, latency would be an issue there, right? So you probably want to move the database and the website both up into the cloud as well, right? If you're going to go to that step. Does that make sense? right? And you actually have a lot of choices for how you go about doing that. Every one of those, there's various ways you could do it. I mentioned, moving the resources up into blob storage. I could move the web up into a website. That could also go into a web role inside a cloud service, or it could go into a virtual machine that just has IIS installed, or what the heck, a Linux box that has Apache installed, right? And it's a PHP site for all I care, right? The database could be a SQL database, or it could be a database engine running in a virtual machine, including Oracle. We now support Oracle licenses running in virtual machines inside Azure. So you get to this idea of lift and shift, right? Sort of taking a site that you have or an application that you have running on premise, sort of lifting it up and shifting it over to the cloud in some form or fashion. So you can build virtual machines up in the cloud. And the idea is that you're going to be able to build those much quicker than you can often do on premise. I was always surprised to talk to people who had Hyper-V or whatever in-house, but still had to wait sometimes days or weeks to actually get a VM provisioned, because there's this whole billing process and approval process, and somebody's got to go figure out and all that kind of stuff. And a big part of what we look at from a cloud vendor is self-service. Right? I want to go in, I want to click a button within a few minutes, have a virtual machine up and running. Requires upload and installation of application and data. So if you're going to move your website or whatever your application is into an Azure VM, you somehow have to get your application and all the resources it needs up into the cloud, right, so that it can get it. So that could be copy and paste, or it could be moving them to a central store that the VM also has access to, or whatever. You could also take an existing infrastructure that you already have. If you're already virtualized, or even physical, you could take a virtual image of a physical box, right, and then ship that virtual machine image up into Azure, and then build a VM off that. So all of your apps already installed, everything's already configured. You just sort of take that VHD and ship it up to Azure, one of various ways here. It does mean, though, that somehow you've got to get this large VHD, right? I'd say you're pretty hard-pressed to find a virtual hard disk image that's less than 10 gigs. And that's probably just a clean OS install, right? After you install all the other stuff on there, these tend to be pretty large. And so uploading them across the wire can be relatively time-consuming. We have PowerShell commandlets to help you do that, and to be able to restart failed uploads and all that kind of stuff. We also just announced that we support physical shipping. So you can create a disk that has the image on it, ship it to the data center, and we can get it off that way as well. So if you think about a lot of your applications on premise, they're not always just one virtual machine, right? I've got a website running in one VM, I've got my database engine running on another VM, I might have some middle tier services running on another VM, etc. And so on premise, I know where they all are, and I'm managing that network, right? They're also behind my firewall and all that kind of stuff. As you ship those virtual machines up into Azure, they're all possibly going to run in a single, what we call cloud service. And the cloud service in Azure gets used a couple of different ways. The most basic use of a cloud service is that it's the boundary around a collection of virtual machines, right? And that boundary would be a firewall as well as a load balancer, right? And so by default, all the machines that run in a single cloud service can find and talk to each other directly. It's like its own little private virtual subnet that these guys can all talk on. There's also a firewall that prevents any traffic from coming in from outside the cloud service unless you go open up endpoints in that firewall. And those endpoints can point to either specific machines, or they can point to the load balancer and be distributed across multiple machines within there. So that's okay. You can take multiple virtual machines, ship them all up as VHDs, and then create VM instances off of those VHDs that are all running in the same cloud service, and they can all talk to each other. IP addresses are going to change. You might have to think about how you're doing name resolution and that kind of stuff in there, but it is reconfigurable and you can do that. Does that make sense? All right. So virtual machine migration, again, I mentioned Windows Azure supports the VHD file format. So if you're running Hyper-V, nowadays it wants to default to creating a VHDX. And you can't run VHDXs in Azure, but the upload tools support conversion on upload, or you can also use the Hyper-V tools to go in and convert from VHDX to VHD. If you're creating a local image for the purpose of shipping into Azure, just create it as a VHD up front, right? Which usually means you have to go make the disk first, and then when you create the VM, you say use an existing disk and you point it to a VHD, right? I think the current Hyper-V tools don't let you make VHDs as part of the wizard. You have to, they want to force VHDX on you. And of course, if you're using another vendor's virtual hard disk format, there's a plethora of conversion tools out there that you can use to get up into a VHD. Once you have them then, we have a PowerShell commandlet called add Azure VHD that you can use to ship these large VHDs up. And again, supports things like failed transfers, converting from dynamic to fixed and into VHDs, efficient upload, doesn't ship the empty bytes. You know, a lot of the times you have these files that say they're 129 gigs, but there's, you know, maybe only 20 gigs worth of data in them, so it doesn't ship the zeros up there as well. One thing before you upload an image on premise, there's no longer a need to install any agents. Hyper-V and Windows Server already know how to talk to it, but you would want to go in and enable remote desktop so that it's accepting that through the firewall and that the remote desktop service is turned on, right? Then once you get it up in there, you'll create an endpoint that says, hey, yes, let remote desktop traffic through that firewall so that it's up and running in there. So as an example, let's say that on premise, I've got a virtual machine. The idea there is its name is AppSRV1. It's an 8 gig machine. It's got 4 cores. And we've got firewall ports open for port 80 and for port 443. And then I've got 3 different drives out there. I've got my OS drive, and then a data drive and a log drive on that VM. As I ship that, first of all, I'm going to have to go ship the various VHDs up into Azure. Right, so that's again going to be time consuming just because you have to ship them across. If you prefer, again, you can go check out, and I'll show you a blog post on it here. We support secure import and export, where you can ship us BitLocker encrypted drives that have your VHDs on them. We'll get them to a data center, extract them out, and then get them into your storage accounts for you so that then you can build VMs off of those. Once you have the VHDs up, though, you're then going to go and create a virtual machine that uses the C drive as its OS. And then once it's up, you can attach the additional drives as additional drives inside the VM. It could be that as you do that, you'll run into drive letter collisions, or you might have to change some of the drive letters as compared to what they were on-prem. So any configuration that you have to do to change paths to, like, for example, where the data files were, if it was SQL Server, you know, reattaching the databases from the new drives or whatever that happened to be that was in there. Oh, okay, yeah, so create the VM and adjust for the drive letters. The last point would be opening up the endpoints, right? So the OS, because on-prem you'd already opened up the ports, right? The firewall should already have port 80 and 443 open inside the Windows OS. But the cloud service is still standing guard and saying, no, we're not going to let port 80 and 443 get to the VM in the first place to be able to make it through its own firewall. So the cloud service has its own endpoints you'll have to go open up so that that traffic can make it through to the virtual machine behind the scenes. So yes, you can. You can do virtualization. Yes, you can take VMs that you have and migrate them up into the cloud. You can also create brand new VMs in the cloud. How many of you are IT pros in the room at least? All right, so I got maybe about 5 or 6 hands show, right? So that's pretty sparse relative to the crowd here. Most of us aren't IT pros. Right? How many of you love installing operating systems and virtual machines? About the same number of hands went up, right? So if you don't want to have to manage VMs and ship VHDs and all that other kind of stuff, that's where we want to move out of infrastructure as a service and move into platform as a service and say, man, couldn't somebody else just take care of these VMs for me? Let me just write my code and ship it up there, right? And let somebody else figure out how to deploy it, make sure it's healthy, reinstall it if it fails, you know, take care of those VMs for me, install the service packs, etc. Or I don't even want to worry about VMs. Just give me an IIS site that I can go deploy stuff into, right? Even less control, but less responsibility, right? I don't have to go do all this stuff, right? So when we say state of the right, we're really talking about infrastructure as a service being on the left hand of that scale, and this is state of the right only works if you draw things the right way, right? Software as a service on the other end of the extreme. Your life is simpler as you move further away from infrastructure as a service and further towards software as a service, right? Of course, if we go completely to software as a service, we're no longer devs, we're just consumers. Right? So platform as a service for me as a developer is really that sweet spot. I want to write my code, I'm going to leverage your platform. I'll just ship you my code. So why PaaS is faster? Because I'm not having to go ship VHDs up and worry about moving all of this pre-configured virtual machines or all that kind of stuff. It's cheaper in the sense that I have the ability to run web farms very simply. And for example, I could probably get better performance and scalability out of 4 small VMs than 1 big VM. Right? And I get load balanced, I get scalability out of that, fault tolerance, whole bunch of cool stuff. PaaS is also lower risk. I didn't have to go and invest all this time in creating these virtual machines. I can just deploy my code up there, see how it works, and then move from there. So the other thing is that you can connect your cloud resources onto your real on-premise site stuff. So you have the ability to have virtual machines and cloud services running in Azure that you can directly connect to from your on-premise networks, or vice versa, that have access. So I could have a VM running in Azure that's actually domain joined, right? That's a real node on my domain, or I could even have a domain controller running in Azure if I wanted to for some reason, right? So you have a lot of choices there. With Windows Azure Virtual Networks, persistent IP addresses are not a good thing because Azure wants the ability to change things as needed. Right? So if you have persistent IP requirements, you want to think about how you can get around mapping specifically to an IP address and instead think about name resolution. You do have the opportunity to add your own DNS servers if you need to up there. You can create hybrid situations where you use an on-prem DNS to point to resources in Azure, or vice versa. Use Azure DNS, put a DNS in a VM and actually host it inside a cloud service up there if you want to. So for example, up here I have 2 different cloud services. I've got one that's got a virtual machine running in it that has SQL Server installed, and then I have another one that has my web role with a website running in it. And these are separate cloud services, both sitting inside an Azure data center. Well, I could come in here onto this guy, where my virtual machine with SQL Server is, and open up port 1433 through that firewall, right? And let port 1433 through the cloud service and into the virtual machine where SQL Server is installed and actually hit my SQL Server instance. It's a little scary because I've got port 1433 opened up to pretty much anything that can hit that cloud service. I still have SQL authentication standing up for me though, right? So we can have standard SQL auth, or in this case, you could even do Windows auth, right? And the application would have to authenticate to SQL Server to connect, but still having that port open is a little bit scary, but it could do it. And my website could just come through the internet and connect in through port 1433 and gain access to that SQL database. So that works. That's also an interesting story when you know that you want to connect to SQL Server from other nodes out there in the wild, right? And you want to have direct port 1433 connectivity. It's not normal that we want to do that though. So the weakness is latency going through the internet, again, less secure, having that port exposed. The other thing we could do is create a virtual network inside Azure and connect both of those cloud services to that same virtual network. They each get their own subnets. They can route back and forth between each other. They can discover each other with DNS and have direct connectivity through the Azure data center in a secure way without having to go out to the internet and without having to open up port 1433 to the rest of the world. Does that make sense? Right, so definitely a great story if you don't need your SQL Server publicly exposed. The downside of that is you got to go in and set up the VNets, right? Yeah, there's some configuration that you have to go through to set that up. And the Windows Azure provided DNS doesn't span cloud services. So you'd have to stand up your own DNS or have fixed name resolution files or something like that to set that up for you. All right, so let me actually jump back over here. let's first look at creating a VM. So in my management portal, I just went into New, Compute, Virtual Machine, and I've got a couple of different choices. If I go into Quick Create, you're going to give it a DNS name, and then pick your the various images that you want. To really see those, though, I'm going to flip back over and look at From Gallery. And so the gallery, just like we had a number of pre-built website templates that you could choose from as you made websites, we also have a number of pre-built virtual machine images that you can create your own virtual machines off of. So these are pre-configured, in the case of Windows, sys-prepped images that you can use, and then when you install them, you get to give them your own machine names, your own administrator accounts, and it's just a baseline for you to sort of configure on top of. And you'll notice that we've got a number of them. There's a number that are supplied by Microsoft, and they've got them sort of categorized in here. There's just pure Windows Server ones. Notice Server 2012, R2, as well as 2008. We have SharePoint pre-installed on a virtual machine, various SQL Server flavors pre-installed for you, as well as BizTalk Server pre-installed for you. That doesn't mean configured, right? Like with SharePoint, the bits are there, but you've got to go set up your farms and do all that configuration that you would do sort of post SharePoint install. But it saves you that problem of getting the SharePoint bits into the VM, right? And then having to go through that process. They're already there, ready to go. We also have a number of Linux distributions down here that you can choose from. And then I'll mention that there's also what's called the VM Depot. And the VM Depot is open source image library that's supported by the community. You can go create your own Linux-based distribution images, install whatever you want to in them, image them up, and make them available through the VM Depot that other people can come choose from. But let's go to my images. If you have gone in ahead of time and created a virtual machine, you can shut that virtual machine down. Well, first sysprep it, and then shut down that virtual machine and capture an image of it, and it's now an image that you can reuse for future virtual machines off of that. So a great story around this, and like a dev test shop for devs, we to create an image that has all of your dev tools and APIs and all that kind of stuff pre-installed, and somebody can come in and just with, spin up an image here relatively quickly. Down here, there's which ones are supported. And notice there's also a checkbox there for MSDN, but it's disabled for me. And that's because I'm signed in to an account that only has access to the subscription that the business group gave me, right, the Azure product team. And that's not through MSDN. I do have an MSDN subscription, and if I was signed in through that account, that MSDN checkmark would be available. And there's some Visual Studio 2013 images that are available to MSDN subscribers. And you could pick from one of those, and it would be a Windows Server 2012 box that has VS Studio 2013 already installed for you and ready to go. But let's come back up here. I'll just pick Microsoft and Windows Server 2012 R2. And as I go into next, I get to give this guy a name. So I'm actually naming the Windows computer right now, right? And I'll just call it my BSWS demo. All right, and here's where I get to pick from my sizes. So the size of the VM that you choose is not only going to affect the performance, it's also going to affect the billing, right? The smaller you go, the cheaper they are, right? And the pricing is all up in that pricing calculator. I hate quoting pricing because it changes relatively frequently and always for the better, right? So it always gets cheaper and cheaper, but look at the pricing calculator, get current pricing on that. Really, for the most part, once the service is up and running, especially if you're going to load balance it, then you go small, right, to keep your costs low. And then the more you load balance it and add more, you'll get that performance out of those, right? So again, typically you'll find, and this isn't always true, there's cases where it's not, but quite often you'll find that more smaller machines performs as well or better than fewer larger machines, and is often cheaper, right? So you'll want to play around with that. Not all workloads pan out that way, so you'll want to test it, but play with that idea of smaller VMs and more of them versus larger VMs and fewer of them. You can always change this, right? So you could say, well, you know what, I'm going to pick large right now because I know I've got to go and install a bunch of stuff and I want good performance. And once I've got it all set up, I'll shut the VM down and then change its size down to something smaller and then spin it back up again, right? And let it consume fewer resources. So I'll go ahead and pick a medium one here. The other thing you're provisioning, and this is a Windows box, is the administrator username, right? So in Windows, there's a built-in administrator account that's always called administrator, unless you rename it, which is what we're doing right here. You're renaming the built-in administrator account, right? So I'm going to call it dev user and give it a password. You'll notice it doesn't like common passwords. Oops. Oh, cool. I love this in demos. A newer version of the management portal is available. To load it, click OK. If this notification reappears, close and then reopen your browser. So you always wonder what they added. Actually, let's go sign out. All right, I don't see any nodes. All right. The other day that happened to me, and that was right as the Visual Studio launch was going on, and the Visual Studio Online showed up. So on that refresh, but I don't see anything new popping up there right now. That is one cool thing about Azure, though. It evolves rapidly, right? So that's really cool. There's always new functionality coming on board here. Let me go kick this wizard off again, though, really quick, since it killed me. I'll go quicker now. I'll pick Server 2012 R2. This is going to be my BSWS demo. I was going with medium and dev user. And what I was starting to show you is that if you use a common password like PA$W0RD, as I move on there, he goes, nah, sorry, that's too common. You got to come up with something better than that. So I'll use one of my own here. And next on through that. All right, so that was the VM. I named the Windows computer. I created the Windows administrator account and credentials. This is asking me about that cloud service boundary that's going to go around the executing virtual machine instance, right? So when that VM is actually up and running, then that cloud service is protecting it as well as providing a virtual network that it can talk to all the other VMs in the same cloud service without me having to do anything extra, okay? So the cloud service is what any public endpoints are going to be exposed through. And so it's the cloud service that gets the public name. And so that's what it's asking me for here is, what's the name of the public endpoint that users would hit from a DNS perspective, right? To be able to get to the various virtual machines that are inside this cloud service. And so I could come in here and either create a new one, or if you had an existing cloud service that you wanted to add this VM into, right? You had one that was your Windows server and this was going to be your SQL box, right? I want them both in the same cloud service maybe, right? So you'd add it to the pre-existing one. I'm going to let it make a new one here. And you'll notice that it wants to use the virtual machine name that you set up on the last one. That may not be the best choice because this cloud service could have multiple VMs in it, right? And you're naming it after just the first one, right? So let's change it. I'm going to call it my BSCS for cloud service demo, right? Instead of BS Windows Server demo. So that's the DNS name. I'll go ahead and looks nicer lowercase. There we go. All right, and notice it's going to go out and verify that that name is again available. This is .cloudapp.net, right? And yes, you can put custom domain names on top of this if you want to have www.mycompany.com. You know, hit port 80 out here. The next question is, where do you want this thing to go? Right? What data center do you want it to go into? And so I can pick from the regions down below, or if you have created a virtual network and you want to add this cloud service into that virtual network, or what's called an affinity group. And an affinity group is for if I have problems with part of a service and it has to move it, make sure that you move everything in the affinity group with it, right? So I'm not going to deal with that. I'm just going to say stick this cloud service off in the West US data center for me. Virtual hard drives are VHD files, and they have to be stored. And in Azure, the way you store files is in a storage account, right? And storage accounts have tables and blobs and queues. But these are going to be blobs. And so it wants to know what storage account do you want to stick these blobs into for the virtual hard drive. And you can let it go out and make a storage account for you. I have one pre-existing that I like to stick my Azure VM VHDs into. And since I knew that's what I was going to use it for when I created the storage account, I called it Azure VM VHDs, right? So it's easy for me to remember which one that was going to go to. So I'll pick that storage account. Storage accounts, by the way, are free. It's the storage in them that costs money, right? You can have as many different storage accounts as you want. It's what you put into them that's going to start to incur usage, right? So I'll pick that one. And then I'm not going to mess with availability sets. This is going to help me deal with, again, failover issues. I'm going to leave that as is and go on to next. This is where those public endpoints are. It says, okay, look, you've got a Windows box that wants probably remote desktop connections, maybe remote PowerShell connections or something like that to come into it. You can say, well, hey, this guy's also going to be my web server. So I know I'm going to need port 80 to make it through the cloud service into this virtual machine. Or maybe I have, FTP running and I need port, 21 and 20 to be able to make it through or whatever, right? So this is where I could go poke holes in the cloud services firewall to get through to this virtual machine that's running inside there. I'm going to leave those all as is, but notice it gives me one out of the box that'll support remote desktop, and Windows listens on port 3389 for remote desktop. So the endpoint on the cloud service is going to point in to port 3389 on the VM. The outside port, though, is going to be dynamically made up, okay? And that means you'll need to know that port to be able to connect. And the reason why, you might have 4 or 5 VMs running in the same cloud service. They can't all listen on port 3389. So we just make them all dynamic, okay? So I'll let it just automatically make one up. If you knew this was going to be the only one, you could make that be 3389. I don't want that. And you could add other endpoints now. You can always add them later as well. I'll just OK on that. And at this point, it's going out and provisioning that virtual machine for me, all right, and getting that ready to go. And that'll take somewhere between 5 and 10 minutes, probably, to get up and spinning. It's got to get the original image, go make a copy of it for me in my storage account, spin the VM up, get it all hooked up to the VHDs and all that kind of stuff. While it's provisioning, you can come in and attach additional VHDs if you want. Like if you wanted to have another VHD for the data drive or something like that, you can do that down here. And you can attach either an existing one, maybe you've uploaded it and this is your data drive or something like that, or you can just create a new empty one and attach it there as well. But we'll let that run. Now over here I have a VM that's already up and running. And it is in fact part of another cloud service called the webfarmdemo.cloudapp.net. In fact, if I go in here and browse into that, oh, that was going in to manage it. webfarmdemo.cloudapp.net. There it is. Right? So this is another node sitting inside that web farm. Now, you might remember that I had an image for a web farm node. That was the my image one. That's actually an image of this exact virtual machine. Right? And so what I did to create that image was I just went into this VM and said, hey, shut down. Well, first I had to sysprep it. Right? So I remote desktoped into the VM and ran sysprep in it, and I'll show you how to do that. In fact, notice that with that VM selected down here, I can connect to it, right? So I'll hit connect, and it downloads this RDP file, and I can open that up and go ahead and connect. And I believe I used the same credentials on this guy, dev user. I'd tell you my password, but then you'd all hack into it and I'd be in trouble. No. All right. Now, remember, I'm already RDP'd in somewhere, so I got to be careful here. If I get out to the C drive, inetpub, www root, Here's the ASP.NET site that's, you know, feeding back that IIS1, and it's just returning the computer name is all it's doing here. So actually, I'll just leave all that as is. All right. So all I did then is come into this guy and run sysprep. Actually, let's go out to right, and you'll notice that sysprep is it's a built-in system tool. It's part of your Windows Server install. So I just went out and ran sysprep here, and it says, well, what do you want us to do? And I'm telling it, I want you to roll this system back to where it would be right after the post install, right? The out-of-the-box experience. Imagine going out and buying a server from the vendor of your choice, right? And you plug it in, you turn it on, you still have to customize it. That's the out-of-the-box experience, right, that you're walking through. Giving it the computer name, generating a new SID for it, setting up the administrator account and all that. Basically, everything that I did is I ran through the VM configuration portal to set up, you know, I gave it a new name, a new administrator account, all that good stuff, right? So I'm telling it to roll this setup back to that point, and then I would tell it to go ahead and shut down that VM, right? And so it's going to generalize the system and shut it down. And once it's been shut down, then I'm going to jump back over to my management portal, and I'm not going to do that right now. Jump back to the management portal, and with that guy selected, I could capture that image. Okay, that capture button would be available. Now when you capture it, it creates an image drive and then deletes the original VM. Okay, so now you have this guy ready to go, and then you can create new VMs off of that image. So I actually did that. I captured it, it deleted it, and I made a new one called IIS1 off of that image. Right? So that was pretty easy to do. I can come back here and do that myself again. I can come into Compute, Virtual Machine, from Gallery. Remember my images? And here's this web node base image. Cool? So I can pick that guy, go on to next, and I'm going to call it IIS2. Let's make this guy an extra small. Dev user, 1RD. All right. And in this case, I'm going to join it to my web farm demo. Cool? And then it already knows the date. I can't change anything else there. So go on to next. Leave all those default ports. Oh, wait, no. I need port 80. This is a web server. It has a website on it. So I need port 80 to open up on that. Oh, in fact, no, I don't. I'm going to do that through... Actually, that's a good question. Where am I going to do that? We'll do it later, I think. All right, so it's going to go provision that, and I'll show you what I can do with that guy. All right, we'll let that provision. But that's how easy it is to go in and create a new VM off of an existing image, right? You just get your image captured, and then you can go in and create new VMs off of that all day long. And this will have IIS already installed and configured with the firewall rules already set up, everything good to go. Plus, it's already got my website code on there. I could redeploy it, but that's all good to go. And you say, well, what about redeploy, right? If I go back and look at IIS1 and go to its endpoints, notice that I've opened up a separate port for web deploy to go to, right? So if I'm sitting down here in Visual Studio, I can use web deploy, point it up to my webfarmdemo.cloudapp.net at port 8080, and it'll push it into IIS1. IIS1 will be where I deploy to. And then I've got a little script that runs on IIS1 that's a scheduled task that just uses web deploy to sync with the other nodes in the farm. Cool? So, in fact, if I jump back to IIS1 there, you go look at the scheduled tasks. Actually, where is that? There it is. Synchronize. And this guy's going to go out and run this PowerShell script that I have sitting out here that's going to go do the deploy for me. And that guy just fires off once every 2 minutes, 24 hours a day, right? And out there in my scripts directory, I've got this handy little PowerShell script here that basically goes in and calls web deploy and goes and syncs it off, you know, from that, uses MS deploy and fires it off and syncs it with the other nodes out there. All right, and that guy's still provisioning, but notice now that my BSWS demo, the one that I started earlier, has now fully provisioned. And so I can click onto that and go ahead and connect into it, open up the RDP file for it. I strongly recommend as you get into creating a lot of VMs that you try to have some consistency in the names and passwords that you use. Right? You can notice that maybe I'm a little too consistent. I use the same one for everything. Right? These are all demo machines, so if somebody breaks in, oh well, I'll delete it and recreate one. You know, but definitely think about that, especially amongst a team, as to how is it you're going to manage those credentials, et cetera, out there. But notice this guy's taking a little bit longer to load. Like this is, first of all, I made it, oh no, actually this one was medium, but it's the first login. It's got to go set up my profile and do all that other good stuff, right? So it's going to take a little bit more time, and I'll let that chug away. But notice I was able to just remote desktop right into it, and now it's just like a virtual machine on my own network, right? I can get in, do whatever the heck it is I want to, download software, install it, and go to town. How am I doing time-wise here? Okay, good. All right, does that make sense? All right, so take a look at a scenario here of thinking about some different ways that you could migrate an on-premise application up into the cloud, right? So here's the core scenario. I've got a multi-tenanted application that's running in my data center here, right? So maybe this is a scenario where you provide services to a certain industry, right? You're really good at helping car dealers run their business or real estate agents run their business or whatever, right? And so you've built this service that could work for any car dealership or any real estate agent, right? And so you actually have a number of real estate agents and a number of car dealerships that rely on your service and maybe even pull data down and do their own on-premise reporting off of that or whatever, right? So those are my customers, but then my service supports my customers' customers. Right? And so those folks are coming in through a variety of different platforms, right? Windows, iOS, Android, whatever that happens to be. Does that make sense? So the problem with this scenario, and there's a lot of companies out there that have a scenario just like this, is that first of all, I've got this single point of failure on my web server. All right, so of course I could stand up a web farm in-house, right? So yes, we can do that. But now I've got to manage my load balancers and all that other kind of stuff, and I've got more machines running in-house. I also have to deal with the backup and the management of that SQL database. You're still going to have to backup and manage depending on where you move it, right? Or how you move it. But at least those are things that are having to go on-prem, or I'm not getting help doing that. I also have this single point of failure from a network perspective, right? Especially as those are coming into my data center, distributing that load out across multiple personal data centers becomes much harder, right? Maybe I have to have an external DNS that's doing round robin and pointing people off to different web servers. I don't know, how am I going to manage, you know, traffic redirection or whatever out there should my single node fail? And then I also have this problem where as more and more clients start to connect, I'm starting to hit this bottleneck on my servers and on my endpoints and all that kind of stuff. I can't easily scale up because I got to go pull more pipes into my premise. I have to add more racks, more VMs, whatever that happens to be. So that's sort of the problem that we have doing it on premise. So one of the first ways that we could do, or we could look at moving or shifting this into Azure, would be to simply move my Windows web and SQL Server roles into Azure data, or into Azure virtual machines running in the Azure data center. Right? So it's the exact same model. It's just their VMs running in Azure now and SQL Server running up in Azure. Right? And so at least now the maintenance of all the hardware and the physical data center and the real estate and the power and the cooling and all that kind of stuff, I'm letting Microsoft take care of that in their data centers. Right? So I've offloaded that. We've got some sort of estimation of cost over here. Again, please verify cost on your own. Don't ever take a price I say because it's going to change or your conditions might be different. But for this scenario, let's say that I was running 2 large VMs. That's 4 cores each. So that's going to run me about $460 a month for those VMs. The storage of the VHDs is also something I'm going to pay for, right? And so larger VMs are going to cost me more money on storage. But with the estimation here of about 50 gigabytes, that's about $4.75 a month. So storage is pretty cheap, right? About $5 for 50 gigs out there. We also get billed for the transactions against those VHDs, right? So having a VHD sitting there without hitting it is cheaper than a VHD the same size that you hit all the time, because you're going to get a transaction cost against that VHD, right? But still, we're guessing about 10 million transactions and looking at about $1 a month total transactions. So really the core there is compute. It's all around the compute costs of those virtual machines themselves. And again, an estimated around $466 a month for that type of a story. The next thing you could do is say, okay, well, let's get rid of the SQL VM. Let's move the database into Azure SQL. Now, there's some thought you have to go through for that. If your SQL VM was very physical, you cared where your MDFs and NDFs and LDFs were. You were doing partition tables and indexes and all that kind of stuff. If you had CLR objects that were a core part of the application or something like that, those could be reasons you don't go to SQL database, that you stay in SQL Server inside a VM. But if those aren't barriers for you, if you go, oh, thank goodness, I didn't know what an MDF was, then you don't have to worry about them, right? You can just say, hey, use SQL database, right? And so with that, notice we've significantly cut our costs down for the same amount of data by getting rid of those compute workloads. We're paying for it through the SQL database. We don't pay for the compute directly then. So now I only need one large VM, the storage of it and the transactions against it, and a 10 gig SQL database is about $46 a month, okay? There's actually one thing on these slides that's not mentioned because we wouldn't know how to estimate it, and that's egress data. You're also going to be billed for the bits that leave the data center. Okay, ingress data is free. You can ship data into Azure, but you get billed for taking data out of the Azure data center, and unrealistic to estimate that. The next step would be to move out of infrastructure as a service and move into platform as a service. And we take that web application and move it into web roles running inside a cloud service. And web roles are just pre-configured virtual machines. They're Windows boxes with IIS. And we know how to deploy code that can run IIS onto those boxes. You no longer have to worry about the VMs, right? You just worry about the code. And that's really cool because then you ship us the code and you can say, you know what? That's what one copy looks like. Run 10 or run 2. Okay, now 8, down to 5. Make it 20, down to 9, right? And so it's very easy to scale up and down with that. And we can just add nodes or remove them as need be, right? So here, notice that my 4 single core servers with the SQL database on the back end is costing me about the same as the single 4 core VM did with a virtual machine back there. So my cost is about the same, but I'm now load balanced across 4 VMs. And I've got fault tolerance and scalability and all that good stuff out of it, right? Again, hoping that I'm getting about the same performance, but your testing would prove that true or false. Another choice, and this one's probably the most radical, would be to move your server functionality into Windows Azure Mobile Services, right? The story behind this, where this plays out nice, is when you have a lot of clients across a distributed number of platforms, you're invested in REST APIs, and you want somebody to sort of maintain those endpoints and to build the backends for you so you're not having to do all the low-level service work yourself. Mobile services is a great way to provide a RESTful wrapper around authentication, and data storage, and push notifications, right? Plus a whole bunch of additional services out there. The migration of your applications can be a lot more painful here, though, because you're going to take whatever your existing web is or existing application is and sort of having to move that logic into mobile services endpoints, which quite often is going to be rewriting it from C# or VB.NET on-prem into Node.js scripts running up inside mobile services, right? So it's like you really got to want mobile services to migrate an application. Mobile services is awesome for something new. But for migration, you'd want to think through that process and see if the value that you're getting out of mobile services with the convenience of cross-platform accessibility is worth sort of the management that you'll have to do for migrating the code up. But once you get there, it's pretty cool. And with there, we say, hey, look, we're basically going to stand up sort of support for mobile services in my SQL database, and we're cutting down here to about $145 a month to cut my costs. So what do? As you look at my moving across there, you could go pure VMs. You could do pure cloud services. You could do a mixture of cloud services and VMs. You could go all the way to the other extreme for mobile services. I think sort of the sweet spot is that platform as a service, right? Moving the web pieces up into web roles, moving the non-web pieces up into worker roles, and then uploading them up there and letting us take care of the VMs for you. All right. So that kind of gets us close to the end of this first section here. Again, we're not going to do the hands-on labs right now, but the labs for this walk you through some of those scenarios. In fact, one of the first slides I had looked at, how do I take just my resource files and move them up into cloud storage? And once we get those, how do we move the database up into Azure, either as a VM running SQL Server or as an Azure SQL database? And then once I got that, how do I move my website up and look at moving that up into an Azure website? So those hands-on labs sort of walk you through that process. The first lab has you first go in and create an Azure virtual machine, just like I've been demoing from. Right? So it walks you through the steps of building a development machine that runs in Azure. It's Windows Server 2012 R2, it's got Visual Studio 2013 installed, SQL Server Express, and the Windows Azure SDKs. And so there's a step-by-step walkthrough, and that's that first lab. The second lab then has you move your blobs up into the cloud, and then you get a choice of how you want to move your database, and you can do one or the both. And then the last one moves the website and points at the new database. Good stuff? All right.